What if every quiet sunrise was only the first tick of a doomsday clock hidden in the sky above us? What if the gentle golden light that wakes us each morning is not a permanent promise, but the opening note of a cosmic countdown, one that will eventually culminate in the most dramatic and final act the universe will ever stage for our planet? This is not just poetic speculation. It is a reality inscribed into the fabric of physics, written across the eons by the very forces that shaped our solar system from dust and fire. For over 4 billion years, the sun has been the heartbeat of our world. Its golden warmth stirs life from darkness, feeds our crops, and powers every engine of civilization. Yet this fateful star is not as gentle as it seems. Its stability, as we now know, is a temporary truce in the grand war of cosmic forces, a peace that will one day be shattered by the same processes that made life possible in the first place. Imagine a future when the sun's embrace turns deadly. One day, its core will ignite uncontrollable fury. The sun will swell into a monstrous giant, burning hotter and brighter than anything humanity has ever known. Its expanding fire will strip Earth of its oceans, vaporize the air, and melt continents into rivers of rock. This is no myth or distant tale. It is written in the laws of physics. The sun's transformation is inevitable. It will grow until it swallows the worlds that dance around it. Venus will vanish first, then Earth will follow. There will be nowhere left to run from the scorching storm. No shelter from the final sunrise. The countdown cannot be stopped. The forces that sealed our fate began their work billions of years ago, long before the first cell crawled across a tidal pool. Not even our greatest science can halt the coming fire. Consider this. Even as we split atoms and map the genome, the basic math of thermonuclear fusion unfolds relentlessly in the sun's core, day after day, second after second, inexorably marching us toward the moment when stability collapses into chaos. Everything we are, every city, every story, every living soul hangs in the balance. To ignore the sun's true power is to gamble with our future and with the very survival of our species. Think of the great civilizations of the past. The Egyptians built pyramids to honor the sun. The Aztecs offered sacrifices to its rising. The Greeks told tales of Helios driving his chariot across the sky. All of these cultures intuited, in their own way, the sun's centrality to our survival, but none could have foreseen the full measure of its threat. But how did this cosmic executioner come to be? What secrets lie hidden in its fiery heart? To glimpse our fate, we must turn back time and witness the moment the sun was born. Before we can face the sun's future, we must unravel its mysterious past. Let us journey to the dawn of the solar system, where chaos and creation forged our star. Imagine for a moment the universe not as we know it, but as it was. A dark, silent expanse littered with the remains of earlier generations of stars. There was no sun, no planets, only drifting clouds of gas and dust, waiting for their moment. Before the inferno, there was only silence, a starless cloud adrift in the outskirts of the Milky Way. Roughly 4.5 billion years ago, a vast molecular cloud waited in darkness, its gases rich with the ashes of ancient exploded stars. These long-dead giants had scattered the seeds of carbon, oxygen, iron, and other elements, mingling with primordial hydrogen and helium, the raw ingredients for new worlds yet unborn. Then, with no warning, a distant cosmic event, a shockwave from the violent death of a star, struck the cloud. Imagine the titanic force of a supernova, its energy racing across light years, slamming into the quiet cloud and setting a new drama in motion. Gravity awoke. The gas began to collapse, pulled tighter and tighter, spinning faster as it shrank. At the center, pressure and heat built until, hidden by veils of dust, a newborn protostar flickered into being. Over millions of years, the temperature in its core climbed to 10 million degrees, and nuclear fusion finally ignited. In that instant, a cold cloud became the blinding furnace that would define our solar system. Let's pause to reflect on the magnitude of this transformation. The sun's birth is not unique. It is a chapter in a story played out across the cosmos. Other stars are being born even now, each one the potential heart of a solar system, each one a future giver and taker of life. Our sun is just one in more than 100 billion stars in the Milky Way, and yet for us, it is everything. The gravity that triggered its formation is the same force that shapes galaxies, pulls oceans into tides, and keeps our feet anchored to the Earth. The sun is a cosmic inheritance, a gift from the universe's restless, creative violence. The sun settled into its main sequence, entering a long era of relative calm lasting billions of years. Deep inside, about 150 million kilometers beneath the surface, nuclear fusion endlessly transforms hydrogen into helium. Every pulse of this hidden engine releases energy, sending light and heat racing outward. This energy will nurture life, but in time, it will also threaten everything it creates. Yet the sun is far from simple. It is a layered, dynamic sphere, every shell playing a unique part in the journey from atomic chaos to daylight. In the core, fusion rages, an inferno where atoms are smashed together to release unimaginable power. Encircling the core is the radiative zone, a dense region where photons begin their slow, tortuous escape. Here, light is trapped in an endless maze, bouncing between particles for hundreds of thousands of years before it can move on. To put this in perspective, imagine a photon created in the sun's core. It might take as long as 170,000 years to finally reach the surface and escape into space. During that time, civilizations on Earth could rise and fall, ice ages could come and go, and entire species could go extinct. And yet, every sunrise we witness is powered by photons that began their journey long before the dawn of human history. At about 70% of the sun's radius, the convective zone begins. In this layer, energy no longer travels by radiation. Instead, boiling currents of plasma rise and fall in titanic cycles, carrying heat upward like a living ocean. Imagine the scale. Columns of plasma as wide as the Earth itself, rising and falling in a perpetual tidal dance. Energy that took millennia to cross the radiative zone now surges to the surface in only a few weeks. Between these two layers lies the tachocline, a narrow and turbulent boundary where the sun's rotation shifts dramatically. Here, deep beneath the surface, the sun's magnetic fields are born, fields that will one day twist, snap, and erupt, driving storms capable of disrupting planets far away. This boundary is the crucible of chaos, the birthplace of the solar dynamo, and the source of the magnetic storms that threaten our technology and our way of life. Above these hidden layers, the photosphere glows, the visible surface we see from Earth. Beyond it, the chromosphere and the corona shimmer. The corona, a superheated aura of plasma, stretches millions of kilometers into space, a ghostly reminder of the sun's restless energy and its far-reaching influence. During a total solar eclipse, the corona is revealed as a halo of light, a fleeting glimpse into the sun's outermost secrets. When sunlight finally bursts free from the surface, its journey is not over. That photon began as pure energy in the core, perhaps hundreds of thousands of years earlier. Now it races across the void, feeding every plant, warming every ocean, and casting every shadow. Each sunrise on Earth is powered by this epic odyssey, a journey that connects us directly to the heart of a star. To truly grasp this process is to understand not just the origins of life, but the cosmic forces that will someday threaten it. The sun's inner workings are the key to our survival and our future. Ignoring its story means risking the fate of our technology, our civilization, and our place in the universe. But the sun's calm exterior hides a deeper restlessness, one that erupts in storms, flares, and invisible winds. To understand what truly threatens our world, we must look to the magnetic heart of our star. The sun's golden surface glows with tranquil brilliance, but beneath it lies a storm of unimaginable power, one that can reach across millions of miles and shake the very core of our world. We have only begun to understand the true scale of these forces. Consider the analogy of a volcano, calm on the outside, but beneath, magma churns, waiting for the moment to erupt. The sun is a million volcanoes, each one capable of affecting worlds far beyond its reach. Hidden from direct view, a vast and restless engine churns. Deep inside, at a boundary called the tachocline, superheated plasma whirls with electrical currents, twisting and tangling into colossal magnetic fields. These magnetic forces are not static. They surge outward, sculpting the sun's surface and driving eruptions that can ripple all the way to Earth, threatening every layer of our technological civilization. The sun's magnetic might is in perpetual flux. Over a period of about 11 years, its intensity swings from calm to chaos and back again. This repeating pattern, known as the solar cycle, governs the rise and fall of solar activity. During solar maximum, sunspots multiply, violent storms erupt, and the risks to Earth mount. At solar minimum, the sun's surface appears quieter, but the next cycle is always waiting to unleash new tempests. Let's bring this down to concrete terms. During the solar maximum of the early 2010s, satellite operators around the world braced for impact. In 2013, a massive coronal mass ejection missed Earth by only a few days. Had it struck, experts estimate that the resulting geomagnetic storm could have caused widespread power grid failures, disabled satellites, and crippled communications. An event potentially as disruptive as the legendary Carrington event of 1859, but in an era infinitely more dependent on technology. When magnetic fields become too twisted, they can suddenly snap and reconnect, releasing staggering amounts of energy. Solar flares burst forth as searing flashes of X-rays and ultraviolet light, while coronal mass ejections, gigantic clouds of charged particles, are hurled into space at millions of miles per hour. If one of these storms is aimed at our planet, it can set the sky ablaze with shimmering auroras, wrapping the poles in curtains of green and red. Yet, this spectacle comes with a hidden cost. Solar storms threaten the essential systems that modern life depends on. Satellites orbiting high above can be damaged beyond repair. GPS signals can be lost in the static, and astronauts may find themselves exposed to dangerous radiation. On the ground, power grids can be overwhelmed as surges race through metal cables, triggering massive blackouts that leave millions in the dark. The sun's storms target the backbone of global communications, navigation, and energy, placing the stability of our civilization at risk. History offers chilling reminders of what the sun can do. In the mid-19th century, the Carrington event unleashed a solar storm so fierce that telegraph wires caught fire and auroras flickered as far south as the Caribbean. In recent years, near misses have brushed past Earth, close calls that could have spelled disaster for our interconnected world. Experts warn that a direct hit could cripple our infrastructure, causing damage worth hundreds of billions or even more. The stakes only grow higher as we tie our lives ever more tightly to satellites, digital networks, and constant power. One unguarded moment could trigger a cascade of failures across continents, plunging cities into darkness and silencing the hum of daily life. Our growing dependence makes us vulnerable, unless we remember how unpredictable and restless our star truly is. Yet, the sun is not our only cosmic adversary. Beyond our solar system, forces from the wider galaxy can breach even the sun's protective shield. What happens when dangers arrive not from our own star, but from the deep reaches of the cosmos itself? The sun is our first line of defense, but it is not invincible. Beyond its reach, new threats loom, challenges that may test our resilience on a galactic scale. Cosmic rays, for example, are high-energy particles born in distant supernovae and black hole jets. These invisible bullets streak through the galaxy at nearly the speed of light, and while the sun's magnetic field acts as a partial shield, some inevitably reach Earth, where they can disrupt electronics, alter DNA, and even trigger mutations that shape evolution itself. What if the delicate machinery of our solar system is far more fragile than we ever dared to believe? The orbits of the planets, so seemingly stable, are in fact subject to tiny nudges from passing stars, rogue planets, and even the gravitational pull of the galaxy itself. Over hundreds of millions of years, these slight perturbations can add up, nudging planets into new orbits, or even flinging them out of the solar system entirely. For centuries, we have imagined the planets as celestial dancers, tracing steady, time-worn loops around the sun, a cosmic ballet with the sun at its luminous center. Each orbit, each year, seemed a promise of stability, a reassurance that the universe would keep spinning in its familiar patterns. Yet this vision is a comforting illusion. The sun is not a fixed beacon, but a restless traveler, endlessly circling the heart of the Milky Way. As it journeys, our entire solar system is swept along, threading through a galaxy crowded with stars. Now and then, these stellar neighbors drift perilously close, sometimes within a scant few light years. Even when separated by trillions of miles, their gravitational fingers can reach us, tugging at the solar system's outer edges. Recent discoveries have upended our assumptions. Astronomers now know that even the gentlest of these cosmic encounters can magnify the chaos already lurking in the solar system's architecture. Each passing star, each subtle nudge, ripples outward, destabilizing the orbits of planets and distant icy bodies alike. Over millions or even billions of years, these disturbances accumulate, transforming small uncertainties into real risks. The statistics are sobering. Computer models suggest that Mercury, the smallest planet, could be nudged into orbital resonance, its path growing so erratic that it might collide with Venus or plunge into the Sun, possibly in as little as several 100 million years. Further out, Mars and Pluto, lighter and more remote, face a chance, however slight, of being hurled into interstellar space, lost forever. Even Earth, for all its apparent security, is not exempt. Within the Sun's expected 5 billion-year lifespan, there exists a measurable risk that a cosmic mishap could destabilize our world's orbit. But perhaps most disquieting of all is the specter of a stellar flyby. Should a rogue star stray within just a few 100 billion miles, a cosmic bush that is rare but not impossible, its gravity could unleash disaster. Such an event might scatter comets inward, scramble the outer planet's orbits, or even fling a planet into the void or toward a cataclysmic collision. This means Earth's safety is not simply a function of the sun's slow and predictable aging. Instead, our planet's fate is balanced on a knife edge, exposed to both the clockwork ticking of solar evolution and the wild, unpredictable dice rolls of our galactic neighborhood. In the face of these distant dangers, a new hope emerges. We now wield tools that allow us to peer deep inside the sun, reading its magnetic fields and internal rhythms, unlocking knowledge across scales that once seemed beyond human reach. The field of helioseismology, for example, lets us listen to the sun's vibrations, much as geologists use earthquakes to probe the Earth's interior. Every sound wave that ripples through the solar plasma carries information about what lies beneath the surface, information that helps us forecast storms, predict sunspots, and better understand the forces that drive our star's cycles. But what exactly do we see when we peer beneath the sun's brilliant surface, and how might these insights determine our future? The answers reveal both beauty and warning, shaping our understanding of what lies ahead. Every secret we unlock about the sun is more than a scientific triumph. It is a lifeline for humanity and a window into our cosmic identity. Consider the example of space weather forecasting. By monitoring solar activity in real time, agencies like NASA and the European Space Agency can now issue alerts to satellite operators, airlines, and power grid managers. This advance, unthinkable even a few decades ago, is the direct result of our willingness to invest in solar science. The more we learn, the safer we become. In only the past few years, a new generation of telescopes has exposed solar mysteries once thought unreachable. Instruments like the Daniel K. Inouye Solar Telescope and NASA's Parker Solar Probe now reveal the sun's surface in almost unbelievable detail. For the first time, we can trace razor-thin magnetic filaments, some barely wider than a few dozen miles, writhing, tangling, and snapping across the solar face. These are not just beautiful patterns for astronomers to admire. They are fingerprints of the invisible forces that trigger solar storms and hurl energy through the sun's churning atmosphere. Why does this matter here on Earth? Because the tiniest magnetic twists may hold the secret to predicting the sun's most dangerous outbursts. Solar flares and coronal mass ejections, unleashed by magnetic chaos, can fling billions of tons of plasma toward our planet with almost no warning at all. When these storms hit, they threaten to cripple satellites, scramble navigation, black out power grids, and endanger astronauts in orbit. The more we learn about the sun's hidden engines, the better we can forecast these threats and shield our technology, our infrastructure, and our way of life. But this quest is far more than a matter of survival. To study the sun is to satisfy a deep cosmic hunger. Every new insight into how energy surges through its layers brings us closer to understanding the rules that shape all stars and, by extension, all worlds. To ignore solar science is to risk being blindsided by disaster, but it is also to miss out on the awe that comes from glimpsing our universe's hidden order. Think of the moment when Galileo first turned his telescope to the heavens and saw sunspots, imperfections in what was once thought to be a perfect sphere. That single act, simple yet revolutionary, opened a new era of understanding, one that continues today. There is an even deeper urgency. Every atom inside us, from the iron in our blood to the calcium in our bones, was once forged in ancient stars like our sun. The energy that warms us, the very light that makes life possible, is a legacy of suns long dead and scattered. In studying the sun, we search for our own beginnings. We are reminded that we are not strangers to the cosmos, but its children, woven from stardust, shaped by the relentless pull of gravity and the passage of eons. If we choose not to invest in understanding the sun and preparing for its tempests, we risk far more than just technological setbacks. We risk turning away from our own story, forsaking the opportunity to discover our origins, and to decide whether our civilization will endure to witness the sun's ultimate fate. Yet the sun's story is not only about origins, it is also about endings. What awaits Earth as our star ages, and how do we prepare for the ultimate chapters of its life? The answer is as much a challenge as it is an invitation. The sun's saga is inseparable from our own, its story still unfolding above us, shaping every tomorrow we dare to imagine. From the earliest myths to today's cutting-edge science, humanity's destiny has always been bound to this cosmic furnace. Our ancestors watched the sun's path across the sky, built monuments to mark its solstices and equinoxes, and wove its cycles into the fabric of their cultures. Today, we study its inner workings with instruments that can detect changes smaller than the width of a human hair, and yet the awe remains the same. For more than 4 billion years, the sun has been both a giver and a taker. Its light sparked the chemical dance that led to life, yet deep within, forces are gathering that will one day spell Earth's end. Each sunrise is a gentle warning. Even the brightest stars must one day fade. The story of the sun's life is written in the rocks beneath our feet, in the rings of ancient trees, and in the DNA of every living thing. It is a story of creation, sustenance, and, eventually, destruction. We owe our very existence to the sun. Our air, our oceans, our memories and dreams all trace back to its energy. But beneath its golden surface, turbulence brews. Magnetic storms twist and surge, and the sun's aging core slowly changes the balance of our world. Our power grids, satellites, and communication networks are at the mercy of its outbursts. The safety of our civilization rests on understanding this unpredictable star. To turn away from the sun's lessons is to risk everything we have built. From the earliest myths to today's cutting-edge science, our destiny has always been bound to this cosmic furnace. The sun's internal struggles are not distant. They shape our climate, threaten our technology, and determine the fate of all life on Earth. Someday, in a far-off epoch, the sun will balloon into a red giant and pull Earth into its blazing grasp. This cosmic finale is not just a matter of fate, it is a summons to act. We must study, watch, and respect the sun, so we can protect our home, adapt our inventions, and brace ourselves for challenges we can barely imagine. What does it mean to prepare for an ending so distant, so immense? Consider 3 practical steps. First, invest in space weather research and early warning systems. Just as we have learned to forecast hurricanes and earthquakes, we must learn to anticipate solar storms. Second, harden our infrastructure. Design satellites, power grids, and communication networks with solar events in mind. Third, foster a culture of scientific curiosity. Encourage education and public engagement so every generation values the knowledge that can shield our world. Historical parallels abound. When the Black Death swept medieval Europe, ignorance was as deadly as the plague itself. When the first atomic bombs detonated, those who understood the science were best equipped to lead the world through the nuclear age. The lesson is clear. Knowledge is not just power, it is survival. The sun is not merely the center of our solar system. It is the heartbeat of life itself, reminding us how fragile and extraordinary our place is in this ever-changing universe. By learning the sun's secrets, we not only guard our world, we claim our place in the larger cosmic story and ensure that our legacy endures beyond the final sunrise. Let us close with one final scenario, a vision of hope. Imagine a future civilization, centuries or millennia from now, standing on the threshold of the sun's final transformation. They have mastered the science, harnessed new sources of energy, perhaps even built cities in space or migrated to distant worlds. Their survival is not an accident, but the result of choices made now, choices to study, to prepare, to dream beyond the horizon. Our actions today can echo across the eons, shaping the fate of generations yet unborn. The doomsday clock is ticking, but it is not too late to prepare. Every new sunrise is a reminder. The story of the sun is not just about endings, but about possibility, about the power of knowledge, the resilience of life, and the courage to face the coming dawn with eyes wide open.